Japan's Kansai International Airport is the world's first offshore airport constructed on an artificial island. The airport accommodates 30 million passengers every single year and generates net profit of 100 million USD. But how on earth did engineers construct such a structure? What were the challenges faced during the construction and what are the key learnings from this undertaking? Stay tuned to find out. Now, in order to understand why the construction was done on an artificial island located offshore, let's first clarify the background behind why there was a need of airport. If you look at Japan's map, you'll see that cities, while Tokyo is located central east, cities like Osaka and Kobe are located far west. Tokyo's Narita International Airport was used increasingly by passengers as well as businesses. This affected the business negatively in cities like Osaka and Kobe. But Osaka had their own international airport, and what was the need of constructing another one? The thing to note here is that Osaka's airport was limited in size and it couldn't accommodate the increasing number of travelers. Secondly, it was located in urban area and it was not possible for the government as well as construction companies to expand the airport. Hence, the construction of airport was inevitable. But then here the question here comes, why not construct it on land and why to construct it on an artificial island? This was thought by the planners as well. And initially the plan was to construct it near the city of Kobe, but the city of Kobe rejected the plan. Furthermore, the government and construction companies didn't want to interfere with the farm's land, as this might lead to large-scale protests like those seen during the Narita Airport's construction. Hence, after ruling out all the options, the planners and government decided to construct an artificial island. Now let's have a look at the challenges faced during the construction. The first one being unstable ground condition. For any construction to happen, the foundation needs to be solid and stable. If the foundation is not stable, this can have disastrous consequences on the structure itself. Since the work here was to be done over water, the ground conditions were not solid and stable enough to hold the structure on top. The main challenge imposed here was by the material known as high alluvial clay that was present underneath the water. This clay holded up to 70% of water. Whenever construction is done on such a material, clay gets compressed. This leads to uneven settlement of the building, having disastrous consequences. In order to overcome these, engineers decided to use something known as sand drains. The idea was to excavate holes around the entire area of the island. Inside these holes, pipes were inserted, and inside these pipes, sand was used to fill these pipes. The sand has small size particles and open pores, so that water can flow through this sand very easily. Once the pipes are filled with sand, the pipes are removed, leaving sand columns intact. Now, whenever construction is done on top of these sand columns, the clay will get compressed, the water will squeeze out and will flow easily through sand. This leads to clay getting dried and the ground getting more stable. Although the ground was stable, engineers still predicted that it might sink in between 19 to 25 feet. However, the design of the structure was done on the estimation that ground will sink up to 19 feet. Phase during the construction was the sinking of ground after construction. During the design, rising of sea level was considered. Engineers predicted that the entire structure will sink 19 to 25 feet during the initial phase, but will stabilize at 13 feet above the sea level. Now, this elevation was the minimum required to prevent flooding. However, in 1990, just 3 years after the construction, the ground sank around 27 feet. In order to overcome this, engineers decided to use hydraulic jacks underneath the terminal columns. These jacks can lift the columns up. Additionally, iron plates are also kept underneath these jacks for further load stability and distribution. Lastly, all the 900 columns are attached with a meter. Now, this meter can monitor excess tilting and can notify the engineers if the column has tilted excessively. Although the entire structure has withstood one earthquake and one typhoon, the lifespan of the structure is uncertain. Till date, the entire structure has sunk 38 feet and engineers have predicted that it is going to sink more. Last but not the least, the third challenge that was faced was the high initial cost investment. For the entire construction, around 14 to 15 billion US dollars were spent. On top of this, around 150 million dollars were invested just to raise this seawall that had sunk faster than expected. To overcome this, airport authorities decided to charge higher landing fees. This means that for the aircraft company to land an aircraft in Osaka, they had to pay $10,000, while the same company can pay $2,500 to land in New York and $8,500 to land in Tokyo. Despite the higher cost, the airport receives a lot of visitors. On an average, every year, around 25 to 30 million visitors are accommodated by the airport. Last year, it generated an operational revenue of 1300 million US dollars, while at the same time they generated around 100 million US dollars as net profit. From the entire case study, I have summarized four major learnings. The first one is to use innovative engineering principles. Engineers used sand drains as well as hydraulic jack to construct a structure on challenging ground conditions like alluvial clay. This means that the engineering principles must be adapted according to the challenges faced. The second one is to plan strategically. Airport was constructed offshore purposefully in order to avoid the expansion problem which was faced in the Itami airport and account for larger needs. The third one is to account for uncertainty. No matter how well the project is planned, uncertain costs and changes will always arise, and those has to be planned as a matter of factor of safety. The last one is to consider impact of the project on potential community. Government built the airport offshore in order to avoid the potential conflict and protest from the farmers. That's it for this video. If you found any value in the video, please like, subscribe and share. I'll see you in the next video. Till then, keep engineering.